Good morning, everyone. Welcome to the first session for Wednesday. Rapidly getting through the kick sessions now. And we've got Mark here again for his second session from Hursley. This time, Mark's talking about Kafka with kicks. And Mark, as you've done it before, but normal rules apply. Everyone's on mute, but if they ask any questions, they can put them in chat, and Nick probably or myself will keep an eye on the chat and try and find a convenient point to maybe pose a question to you between slides, etc. Okay, without further ado, Mark, please take it away.
Okay, thank you, Rob, and thank you to the GSE team for inviting me for this second session on Kafka and kicks. Just say, hope you're all keeping well. My name is Mark Cocker, so I'm the kicks product manager, and I've had the pleasure of working with the kicks team for quite a number of years now. So there are lots of links throughout this presentation. So do feel free to download it and sort of click on those links to get to the various materials. I didn't want to smatter the presentation with lots of URLs, so it's just highlighted text in the PDF that you can download. As Rob was saying, ask questions in the chat. I'm also going to be joined by hopefully a colleague from Hursley, Matt Lemming, who's in our messaging team, and he's had a little bit more experience with Kafka and interacting between MQ and Kafka. So if you have those sort of nature of questions, we'll perhaps save those up for when Matt joins us towards the end of this session. Okay, without further ado then, so producing and consuming messages in Kafka from kicks applications. So this presentation was really in response to several customer conversations we've been having recently about how they can produce and consume messages in Kafka applications. And these customers tend to have had extensive use already of Kafka in their organizations, probably on distributed systems, and typically interconnecting a number of different applications and platforms, and they've sort of have started to use it as their central event-driven sort of hub, if you like. So these customers tend to have skills already in setting up and reliably running their Kafka clusters. And also they tend to have developers who've got the skills to write and deploy Kafka client applications on those different systems to, sort of produce, consume, and also process messages as part of event streams, which we'll get onto in a later slide. So the power really of event-driven architectures and the use cases are really to gather up live data streams from lots of those disparate systems, and then find ways of combining and using those data streams to really provide new experiences for customers. So that's what it's all about. That's why customers tend to be interested in Kafka. And so what I proposed is that, I just put a few slides together here just to introduce you in case you're, on the kicks team and perhaps not as familiar with Kafka as other people in your organization. And also maybe just give you some pointers as to where you could get going and how you could start, as I say, producing and consuming messages in kicks. So with that in mind, this is the agenda. I thought I'd talk just a few slides on messaging and events in general, and just to kind of articulate a little bit of difference between those two. Then we'll just quickly introduce what Kafka is, and sort of, if you like, elements in a typical Kafka architecture. And then we'll talk about what options and considerations you may have from a CICS point of view when you want to sort of connect up or extract data or process data from Kafka topics, inside a CICS application. And then I've sort of just summarized a couple of use cases that we've heard about from customers, and I'll just walk through a code example, and then we'll follow up with any questions afterwards. So messaging then. Well, messaging really, I think, we're very familiar with messaging on the mainframe in general. Messaging has been an endemic part of CICS application architecture for a while, with IBM MQ, and it's really an essential part, of building the sort of connected, efficient and scalable solutions where those different components of an application architecture tend to be on different platforms and perhaps use very different technologies. So allow those systems to intercommunicate in that sort of reliable, robust way. And as I say, messaging and writing message applications in CICS has been something, that we've been doing for, over 25 years, if not more. And in fact, the original sort of MQ development team were partly working on CICS before they moved over to MQ. So it's a very sort of important part of CICS applications, and the type of application patterns that we tend to see these days are that critical exchange of information, as I mentioned, from one system to another. And in some cases, we need reliable messaging. So we need sort of assured delivery, as MQ referred to it as, or guaranteed delivery, maybe in other parlance. And those systems, because they are swapping data, which is, if you like, on the move, they do need to be secure and really robust, because if that data is moving off the platform, you need to make sure it's secure, obviously. And other application patterns include things like real-time events, and this is where perhaps there's been a lot more focus recently. So instead of communicating between two sort of applications, perhaps used by a user or something like that, these tend to be more real-time events. So you may have sensors or data in various sort of kind of manufacturing or retail scenarios, which are just feeding constant data, or perhaps you've got oil rigs, all those sorts of things where sensors are an important part of running that production scenario. But then if you interconnect that data, it can add more and more value as systems and dashboards and automation and AI can pick up on those things. And then event streaming is also becoming popular. So adding value, if you like, from one stream of data or potentially multiple streams of data, adding value by processing that data and then putting that information back on a stream for consumption by other users. So these are sort of typical application patterns, and architecturally, what we're talking about really are messages sort of traveling from one application to another, or events, and that's really a sort of communication system, if you like. But there's another aspect to Kafka and components like that, and that is they can be used to act as a persistent data store for events. So rather than our traditional mental model of events on MQ, where messages arrive, they get buffered and stacked, and then they get processed, and they tend to be a destructive read, where messages are taken literally off a queue, processed, and then thrown away, and it's, you know, it's a system for buffering data. Kafka has a different a set of capabilities which allow you to actually persist that data over extended periods of time and also extended systems. So, you know, there can be replication of Kafka topics, and that data can be, if you like, partitioned and kept on one or more of those parts of that cluster. And so what can happen is clients can write data to those topics, and then, you know, one or more clients can come back and read that data and later reread the same data, or catch up or skip, you know, data, because it's it can be a persistent store for a period of time that you get to define. Okay, so just to I guess highlight a few sort of differences between message queuing and event streaming. So message queuing traditionally has things like, as I mentioned, it's transient data, so it's messages going on and coming off, and they tend to be persistent in terms of, you know, transactionality. So you can take multiple messages off a queue, but then they could be in a bend and you can put them back onto the queue for later reprocessing, that sort of thing. Messaging also tends to have a request reply model. Sometimes it's just an acknowledgement, but, you know, it tends to be that you send a request and the client may wait for a reply, and you tend to target the delivery. So you tend to put it, you know, message on a queue, and there tends to be specific applications putting them on the queue and off the queue. You know, that's usually configured, set up, and then, you know, that's how it's run. And, you know, traditionally only one application is perhaps processing the messages on those queues, albeit for high availability. You know, that may be striked across multiple systems. It tends to be just one application processing. And compare that to event streaming, where, as I say, that there is an element of history taking, or logs, as they refer to them as, and multiple clients can be, you know, adding to and reading that log, and they can read them in batches. We can, you know, they can read them singularly and those sorts of things. So there's lots of different patterns there, and it's a scalable consumption because Kafka is implemented as a cluster, so there tends to be, you know, several systems in that cluster, and data is apportioned across that cluster, and there are, you know, sort of components and features that will make sure that data is not lost by replicating data. So there's a head of the queue, if you like, that owns the data, but if that member is taken out, another sort of elective process happens, and another member will take over that queue. So from a client's point of view, they should see little, if any, disruption, even though there may be, you know, components in the system from a sort of availability point of view, you know, may become unavailable and then restarted, or, you know, upgraded, that sort of thing. And there's an element of data being immutable. So as information is written to topics, it is, you know, if you like, it can't be changed in the future. So there's that adds an element of assurance from a client's point of view, that if they read something, they can be assured that if they reread it in the future, it's going to be the same. Now, you could say, oh, that's you know, that's very clients may want to change that data, and the concept within streaming technologies is, if you want to change or augment a stream, you would create a stream processor, read data, and then create a new topic, and so that users of that augmented data would not read the original topic. they would read from that augmented topic. So you don't go back and change anything. Those, that's immutable, but you're free to process data and create new topics from other topics. And I won't go any more into detail here because we have another session later today given by Matt that is going into this in a lot more detail. And he's got lots of diagrams and examples of those sort of patterns. Okay, so what is Apache Kafka? We've talked about it a lot. You probably have a little sense of what it is. These are the components. So it's an open source project by Apache. So that means you're free to sort of look at the source, participate in the project, raise defects, if you like, issues on Git, etc. Under that project. And it's an event streaming platform. They claim it's used by thousands of customers, and it's known for its high performance, and it tends to be used for things like streaming analytics, data integration, and other sort of critical applications.
Hey Mark,
so
as you're talking about event streaming and everything, we have had a question. How would you position event streaming versus pub sub?
So that's interesting because pub sub is, that's one pattern, as I've got on the right here, that Kafka can be used for. So it's, pub sub where you have, perhaps multiple clients listening on a topic is exactly what Kafka can be used for. So in a sense, that's one of the primary use cases for Kafka. Now, if you're talking about pub sub in MQ versus pub sub in Kafka, I think we best, wait to ask Matt some of his thoughts there, because I don't have much experience of the sort of direct comparison, if you want.
Okay, thanks, Mark.
So just to walk through some of the components and the terminology I'll use here. So Kafka is, as I mentioned, implemented as a cluster, and it's a pure Java runtime, so it can run on lots of different platforms. It can run on, it can run on my laptop. It can run on, x86 servers. It can run on Z-Linux. It can run on z/OS. That's not to say it's supported on absolutely every platform. But it certainly, as a Java application, can be bootstrapped and run, and it just uses Java services, for file I/O and networking. So it's perfectly able to run on many different systems. And you connect in to Kafka, and typically you'll have a set of producers. So these are client applications that are producing messages and writing them to topics in the cluster. You have a set of consumers that are reading typically data from one or more topics, and possibly you'll have components that are both consumer and producer, in what they refer to as a stream processor. So that's reading topics, augmenting or adding value to that data, and then writing them back to new topics. And then you may have external systems which, CICS and MQ, for example, would be examples there, which can write data to source connectors, which then, if you like, act as the Kafka client to write data into or read data from the cluster. And the typical use cases on the right there, as I mentioned, pub sub, things like monitoring activity on websites where you've got lots of data being produced by clients, you know, maybe very small metrics, for example, maybe log information, and you're just constantly writing it to a stream. You know, you can, as I mentioned, define how long that period is. It could be, you know, it could be minutes, hours, days, weeks, months, and you can alter those things on the fly. Actually, one thing that's missing on here is there is also a command line interface. Once you start the Kafka cluster up, you can use a command line interface, and it can act as producer consumer to, for example, create a topic, just read a topic, or write to a topic from a command line. So it can be scripted, and that command line interface can then be the actual sort of component that other components use. So for example, if you had a DevOps pipeline and wanted to write Kafka messages, you could just write a small script that drives that command line interface instead of actually writing code to interact with Kafka. So that's what Kafka is. To get started, I've got a bit of light reading for you here. So to kind of set the scene a bit, IBM has produced an architecture a sort of set of material to help customers sort of understand the event-driven landscape and typical use cases, scenarios, and options. And I've got a link there to that architecture guide, and that's a very good read. It just lays out some of that landscape, some of the terminology very nicely with some nice diagrams. So that's a good place to start, just to get a feel of you know, the environment in which Kafka and MQ and other components work. As I mentioned, there's the session later on today that will also help answer your questions about, you know, messaging versus event streams. And to get going with Kafka, there's a very good material on Kafka's own site for getting started. I've walked through that material myself, and there's a great sort of combination of videos and walkthroughs and code examples, and, you know, step-by-step tutorials, those sorts of things. So, you know, don't be afraid of setting by a few hours and going through some of that material. As I say, it's very consumable, and you know, you'll be able to install Kafka on your machine, create a topic, write a quick sort of set of scripts and programs in no time at all, following those guides. And there's as I mentioned, Kafka itself is written as a Java application, and all of its core APIs are Java APIs. And so you can write Kafka clients in Java and run those on any systems. And that's where we're getting to, of course, is the ability to be able to run those in CICS. And one of the frameworks which help you write Java applications without writing a lot of code and provides a lot of templating and defaults and configuration for you is a framework called Spring. So there's a project called Spring for Apache Kafka, and that really allows you to get going writing Java applications to call into Kafka without actually writing a lot of code. And if you like, there's a lot of skill and experience gone into, you know, making that a very consumable and easy to use API. So if you do want to start writing Java applications and calling into Kafka, I suggest that's a good framework to start with as well. Of course, the core APIs, you know, are very usable. It's just, you know, some of the scenarios and patterns can be got out of the box already with that framework. And from a CICS point of view, if you're sort of new to running Java applications in CICS, we've created a new Getting Started guide and I've got a link to it there, and that just gives you some basics of what the CICS environment's like, some of your design choices for writing Java applications, the APIs that you can call into CICS and other sort of COBOL applications, etc., and how to get going. And we've got some samples. There's no Kafka samples, but there are general Java examples in GitHub. And I'm attempting to put together a Kafka sample at the moment. It'll probably take me another few weeks to get that finished, but so look out for that on GitHub, but there's certainly other Java examples already up there. And there's a blog with a few code snippets, but that was written a year and a half ago now. So I'm hoping that we can perhaps freshen that blog up and provide a bit more sort of detailed guidance in the near future. Okay, so that's how to get going. So what about CICS applications, and what kind of options do you have for calling into Kafka from CICS? Well, I've outlined three sort of ways in which you can interact with Kafka on the left. One, as I mentioned, is by writing a client application. Typically, that will be in Java because that's the primary APIs that Kafka provide. And you can write a consumer application, a producer application, and a streaming application. So those are the core APIs as a client you would typically use. As I've mentioned, they're fairly straightforward to use out the box, but frameworks can help there. An alternative is there are a number of additional implementations written in other languages like Node, C, and there's many others that are built on top of those in order to call in. So if you prefer to write in other languages, you can. There's no bindings for COBOL, so you're really probably within a CICS environment. I'd suggest you use the Java APIs. There's also Kafka Connect, and this allows, this is a project that allows you to integrate other environments into Kafka without having to write applications. So they typically will copy or replicate data from those other systems. And that Kafka Connect also provides a REST API. So in fact, you can interact with Kafka by writing REST API calls into that Kafka Connect component. So anywhere you can call a REST API, you can basically interact with Kafka. And then there's a set of command line tools, as I mentioned, and I found them useful for experimenting and writing a few scripts, maybe testing, those sorts of things. Or indeed, if you're already in a script environment, such as a pipeline, it's just a natural thing to, take data to say, oh, we're at this point in the pipeline, and you could perhaps write it to Kafka topic if that's, needed elsewhere. So taking those as the prime ways of writing or using clients, from a CICS point of view, that means you could write a Java application in CICS that calls the Kafka API. You could write that as an OSGI application and just use the Java SE environment. You could use the Liberty JVM server in CICS and write a Jakarta or Java EE application, or you could use the Spring framework. All of those are supported in CICS. So it really depends what other APIs you want to use as to which of those is appropriate. So I would suggest if you want a really basic Java SE environment and you just want to call maybe exec link from a COBOL program, you want to call the Java program and write to a topic, OSGI is a perfectly good framework for doing that. You could modify a lot of the Kafka examples out of the box, and they would, if you package them as an OSGI application, they would, you just need a bit of extra code to, accept the data from a COM area or channel, something like that, or TSQ, and then use the Kafka APIs just as the examples show you. And, that would work with a very low effort of configuration and setup. The Liberty environment, it takes a little bit more to set up. It's a little bit more heavyweight because you're running a whole, Java EE application server inside of CICS. But it is zip offloadable as Java applications are in CICS. And if you're wanting to use more extensive APIs, then that may be an appropriate environment. And then I've already mentioned Spring as a framework to provide that sort of templating and easy to get going. And that's very popular within for Java application developers. So the other option there is to write a CICS application to call into the REST APIs, and we've had a proof of concept with a customer where they've used ZOS Connect to do that, or you could write your own a sort of REST component either in Java or another supported language in CICS to make those calls. And then the third option there is really just to use straightforward messaging within the CICS application. So using get put messages to MQ and then replicate that queue out to Kafka using one of the source connectors. And there's a number around to do that. And some of those source connectors run on ZOS or are cross-platform. They all provide different qualities of service. So if I go to the next slide, this just sort of puts that same information into sort of diagram form, if you like. So the CICS application, can be a producer or a consumer. As a producer, you could even use a CICS application event, which is an example I've got later in these slides. If you're wanting to send a message out from, say, a COBOL program, you could use a CICS application event to filter and capture the data that you want without actually changing your COBOL program at all. And once you've captured the information, you can then call a program, which in this case would be a Java program, which acts as that Kafka client to write the information out. Or you could just write an application and use an exec_CICS link from that COBOL program. So as a producer, there's a couple of options there, depending on whether you want to modify your program or not. As a consumer, you will have to really write that application because there's no way of sort of automatically injecting data into applications. So you would typically then write a long-running application in CICS, which would listen on a topic, wait for events or messages to arrive on that topic, and then it would spawn off or run in line program. So it would link, or it would issue an exec_CICS start to process that data, or use the async API, something like that. And then, as I mentioned, you could really just use CICS and MQ traditionally as you do today, and then use one of the source connectors or sync connectors to get data in and out of Kafka. So those options also come with a set of terms and conditions, if you like. And so I've just written down some of the considerations that you may have, and this comes down to the type of application architecture you're looking for, the qualities of service, and so on. So one of the important things to think about is the transactional scope. you know, do you want, you know, what is the relationship between the data that you want to, you know, extract or consume in CICS with the data in Kafka? For example, if you have a CICS application, it's partway through running, it has, you know, some uncommitted resource updates, you write to a Kafka topic, and then you carry on doing some more updates, and then you append. There's no sort of transactional processing that happens between the CICS resource updates and the information that you've written to Kafka. So that those, as I mentioned, you know, it's a log that can't be changed once information is written into Kafka. And so you can certainly write compensation or reverse action kinds of messages out to that same topic by Shore. So, you know, in a sense, you can, whilst you can't delete the data, you can put in, you know, additional information into that topic, which says ignore that previous sort of information that was added in the past. But that does add, that sort of compensation type logic does add to the cost of you know, writing and testing, etc., that application. So one option there may be, you know, to use MQ rather than to write the clients directly. Network latency, that's something to consider, that if you've got a high performance application, you've got, you know, sort of a time frame in which that application needs to complete. And now you're starting to write messages out to a distributed system, perhaps. Although that system may perform very fast, you do need to consider, you know, what volume of data you're writing, how available is that application, what happens when there are delays or problems. Do you want to, you know, give it a certain amount of time and time out? Do you want to, you know, throw that away and, you know, complete the transaction anyway? Is it sort of just nice to know information, or do you really, you know, need to write it somewhere, and possibly, you know, an intermediary stage and sort of catch up the Kafka topic later, but not to disturb the actual you know, response time goals that you have for your CICS tasks. So that network latency, you know, when everything's going well, may look great, but do consider, you know, those error scenarios and slowdown scenarios, and similarly with network reliability. If that Kafka cluster is running in a cloud, you know, what's the network reliability and security like from the system that's emitting to the system that's consuming? You know, kind of obvious really, but, you know, all good things to consider. The other factor to consider from a CICS application point of view is typically running in EBCDIC. You know, we've got code page conversion and possibly transformation from, you know, binary types to possibly JSON objects or something like that. So where do you want to do that transformation? Typically, you know, other systems aren't going to understand EBCDIC. So, you know, for their health and benefit, traditionally that sort of transformation is done on COS, and also the application may change and have different, you know, elements, and you know, that sensitivity to the change of binary data is usually best, you know, the transformation is usually best done closest to home, so the teams that are managing that binary data know when to change that transformation. And skills, so most customer shops now have Java skills, and running Java on the mainframe is you know, fairly well understood now. So setting those things up though may be new for you, and certainly running production, you know, Java workloads may be new. So do consider that. And the last one on there is really, you know, whether you have existing products like MQ or ZOS Connect, you know, you may want to just take advantage of them because you already have them and it's just the easy thing that you know and love, and you know, if you like, it's a known risk when you're writing those types of applications. Okay, so I've just put a few example use cases here of where, you know, CICS could be perhaps a producer of messages. I won't sort of go into the details of these. These were just really my sort of ideas and things I've heard from other customers. You know, so you can have, for example, insurance application capturing data, doing transformation into JSON, writing it to Kafka topics, and then you know, producing dashboards where perhaps that you know, insurance claim data is then mapped onto you know, sort of geographical area, and that can be used to spot trends that perhaps if you just were looking at each particular claim, you wouldn't notice those types of trends, and so on. But as I say, I won't go through that here. So I'll just touch on one customer example that I've been through recently. So this was a customer wanting to sort of enhance their, you know, it was a large project. They've engaged with a business partner. They were looking to consolidate their sort of banking suite and to open up new services to customers. And they were, you know, doing this using Kafka. They wanted to extract data from the core banking application and augment that with a number of other services. So what they did was to, this was in a proof of concept, and they engaged with the IBM team, and we, you know, within a week, we're able to put together this kind of architecture just to prove out the sort of technical sort of intricacies of the components that perhaps would be needed. In this case, they wanted the core banking application to remain largely untouched. So they had that continuing to run in the CICS regions that it was, and they made an exec-CICS link from their COBOL application through to a component in a new CICS region that was referred to as a controller. And this prepared a request and used the exec-CICS async API to start a new transaction, which then was responsible for writing the data out to Kafka. So it was a Kafka client. It also did the transformation, so it you know, prepared the data into a JSON format and wrote the message out to Kafka. And if there were failures, it would then write that data to an exception file, and that meant that, you know, requests flow to the system and either succeeded or failed, but there was no delays and no lost messages. And that exception file then would have a separate handling transaction, which would, you know, periodically look at that file and then replay those messages to push them back out to Kafka. So there's elements of this which, you know, that were a customer's choice, but, you know, it just shows you, you know, that the type of environment that you could set up to act as, you know, a Kafka client running in CICS. You know, sure that these systems could have been collapsed. You know, they could have made a simple, you know, link directly to the Java component as well. But, you know, their requirements had them set up this environment. And they're also considering running Kafka on Z Linux, but they didn't for this proof of concept. There was another client that we were working with who had their application running. They were just looking at how to best set up, you know, SSL in this environment, and they were, you know, comparing running with the security set up directly in the Liberty JVM server. So they, configured the Liberty server XML with the appropriate, connection types, and set up the security certs, the certificates in RACF, and configured that with Liberty. And then similarly had those, opposing certs installed and configured in Kafka. And that's how they got that set up. But the environment I think they went with was to actually use ATTLS and have the TCP/IP address space act as the the SSL endpoint, and they found that excuse me, was easier to configure for them, and was higher performance. So I just got a code example now. So this is based on the CICS catalog manager, and the scenario I sort of set up was that if you wanted to order an item out of the catalog, a particular CICS program would be called. So there was, sort of, if you're familiar with a CICS catalog program, it's got a BMS front end, sort of, a 3270 interface, if you like. It's got a catalog manager program, which acts as a central hub, if you like, for handling requests. And then when dispatching an item, it would call a CICS program, in this case, DFH0xSOD. And so what I could do was to, if you like, intercept the request into that program, extract the data, and then send it out to Kafka. So in order to do that, I set up a CICS application event. So I did this using I created a CICS bundle. Within the CICS bundle, I created an event, a CICS event, and within that, I created a capture point for the exec-CICS link program command. And then on the next screen, I then set up a filter which said when the exec-CICS link contains the target program name of DFH0xSOD, then the event would be captured. And then I specified the data that I wanted to capture from that link command. So in this case, it was going to take the data from the COM area, and then you can specify the offset and lengths and the data types of that data. And to make this a bit easier, there's an import capability. So you can import a COBOL copybook and then select the actual items that you want, using a pick list rather than, working out the offsets, which can get a little bit hair-raising when you have different data types. So then we know what data we're going to capture. So then you set up an adapter, and this adapter is really the, specifying how you want to handle the event. In this case, I said I want to start a transaction, in this case, KAFP, Kafka producer. And then I wrote a program in Java. And as you can see at the top there, it's got a Java program annotation. So this is the program that's targeted by that transaction. And when this Java program is installed, because it's got that annotation, it will automatically produce a program definition. Well, it'll install a program definition. So when the transaction is run, it will end up calling this Java component at this particular method. And then the first part of the program gets information about the channel, gets the data from particular containers that are named in that channel, and then formats them so it sort of gets them as strings or whatever it's needed to, and then creates a bit of information, and it populates a Java object to act as a container for that data. And then towards the bottom there, you can see it's creating a key and value. And so these are, traditionally when you write to a topic, you have a key and a value. And they can be whatever you like, but typically the key is some kind of, in this case, the order number, but it could be any sort of identifying information. And then the value is the actual, in this case, the JSON representation of that Java object. So I've got an object wrapper that flattens a Java object down to a JSON document. So I have my key and value, and then I call a static class on a Java object I've called simple producer. And on the next slide, you can see that Java class simply gets a set of properties that contains some information about the connection details. It then creates a Kafka producer and assigns that to a variable, and then it executes the send command on that producer, and it specifies the topic. So that's the actual topic name, the key, and the data that's to be, so the value, in other words, for that item. So you can see here there's very little code you need to write. Obviously there's a lot of exception handling and so on that you would typically add as well. But this was just a proof of concept here. So there's the API can get a lot more detailed if you want to do very specific things, but at a very basic level, just to write to a Kafka topic, this is all the code that you need really. And then the properties file is really defining just a set of name value pairs that the Kafka client APIs use to create that connection. So for example, where is the server? So you've got definitions of the the location of those servers. You can name a number so it can go through. If one's not available, it'll sort of delegate out to others. You can sort of specify what kind of security you want and protocols. In this case, I also added some extra properties around what topic and what type of serialization I wanted to do for the data, and retries and those sorts of things. So that was really my choice to add those as properties. I could have specified them on the client API, but because I was experimenting with different things, I didn't want to constantly be changing the program, so I just put them as a set of properties. So on the left is really the connectivity stuff, and on the right are my choices of properties just to drive this particular application. So that was it really. That was just a quick tour de force of trying to give you some steers as to why we've had customers interested in Kafka, the nature of what Kafka is, and the use cases that those customers are particularly interested in, and just a walkthrough of a code example. I was hoping to actually run that code for you today, but unfortunately I had some user IDs that were revoked, and our system last night wouldn't let me reestablish them. I don't know why. So the demo gods were not kind for me today. So I just walked through the code. But if anyone's interested in seeing that sort of thing running, I can set that up and run specific sessions for you. Or indeed, if you want me to send you the code, just drop me a note and I'll do that. So with that in mind, shall we open it up for questions?
Mark, we did have a question, but Matt's joined and has been answering it in the chat as well. Okay. Matt, I'll unmute you so that you can perhaps summarize the that question and your reasoning behind the answer.
Yeah, sure. Hi everyone. So the question was, right, we've got these sync and source connectors. Can you run them on USS, or run them next to MQ on ZOS? And the answer is that, well, there's kind of two sets of connectors, which Mark mentioned. There's ones provided by Confluent. So those ones, they don't actually say they support them running on ZOS under USS. That doesn't mean they won't. It just means they don't state that support. And I'm not aware personally of anyone doing it. The other set of connectors are the ones provided by IBM, and as Mark said, there's two flavors of those. There's open source ones, and then there's the same set that are provided with support from IBM event streams. Those ones have very specifically been tested and, you know, benchmarked running in USS. So absolutely, they can be running in that environment. We've got customers who've spent a lot of time looking at them, and actually running on USS with MQ is kind of a performance sweet spot in terms of CPU usage and basically throughput as well. So yes, connectors can be run on USS, but probably more likely to be the IBM provided ones, or at least the Confluent ones. It's not obvious that they are supported, so that would be a discussion with Confluent to decide whether they would support them or not.
Thanks, Matt. And Mark, thank you for promoting the Q&A tomorrow,
Yep.
10:30 to 11:30. Please have your questions ready. We've got quite a rich set of Hursley experts who are planning to join that session, so it is a good opportunity for you to ask your questions. And of course, thank you for promoting Matt's session later on. We haven't had any further questions, so Rob, I don't know if you...
I've got a question.
Oh, there you go.
So we were chatting earlier on before the thing started, and obviously Kafka's, we've got a lot of teams looking at this kind of stuff. And it seems to me at the moment, we've got MQ as an interface, which seems to underpin all the interactions that we're doing from CICS. So as with a lot of large companies, people are trying to move bits of applications off host or creating new ones, or trying to exploit data off host, getting things replicated and copied across. But it does seem to me it's a bit like when MQ first came along to the industry. It's a sort of guaranteed delivery, dare I say, asynchronous method that was suddenly used for high volume synchronous traffic because it was kind of good enough. But then we ran into sort of scalability issues further down the line. And I just feel at the moment with our designers and people looking to get pilot schemes now, new ways of working, low volume things running, there's a danger with a lot of this that we end up creating infrastructures that don't scale because of networking latency or whatever you want to call it. So Kafka sounds like a great tool to me, but I'm worried about what it's going to be used for and the implications for us in keeping sort of high volume, fast response systems working properly, because there's lots more bits of wet string here. So
yeah, I'm not sure if that was more of a statement or a question, really.
Well, I think we've just got to be very careful. I'm very interested in the other connectors that were mentioned, and the fact that maybe they were better alternatives than using MQ. And I don't know if there's any sort of stats or comparison between
the connectors. The connectors I mentioned would be using using MQ initially within CICS, and then the connectors really just act as a if you like, a replication process, so that those are very fast and efficient, because they're doing that out of bounds, right? They're using MQ for what it's good for, which is transactionality and high performance, and you can tune it very well with CICS because we've been doing it for many years, and then all the interaction with Kafka is then out of bounds from that application and is potentially zip or floatable.
And do you see the interactions between CICS and Kafka on the platform as being mostly CICS to Kafka, mostly Kafka to CICS, or is it sort of 50-50?
I think it's mostly CICS out to Kafka. So it's mostly other systems that are interested in data points, either for example, not all great information is data at rest, right? Sometimes there is data in flight in the transactions that never gets to be written out, or if it's written out, it's buried deep or post-processed, or a data lake sucks it up once a day, and so it's batch orientated, or it's delayed in getting that information. So I think the sweet spot is getting very precise, targeted information that you need at a very, at the time almost at the time the transaction is executing, maybe half a second behind or something like that, because obviously Kafka is going to end up processing and distributing data and feeding its clients, and that takes time. But it almost near time, sort of data from your transactions is the sweet spot I think we're talking about here.
So I'd echo that. We've spent a lot of time chatting to customers about routing it via MQ, obviously. And maybe there's been about 50-ish of those sorts of conversations, and I can think of only one where it was Kafka coming into the mainframe. It's always out.
Okay, that's probably my main concern, would be Kafka coming in. To be honest, the scenarios that you're kind of outlining, the event-driven posting or notification of data to other platforms, I think it is where I see it. It's just interesting how the designers see it once they get hold of that data that's been sort of posted out, manipulate it or change things, and then we'll want to communicate to applications sitting back on the mainframe via MQ. So at the moment, my fears around a lot of sort of synchronous inbound stuff coming in as a result of us being, a really good citizen and passing information outbound. And then there's a whole infrastructure between going out from CICS, coming into CICS, and it's looking quite complex. But from what I'm hearing from you guys, is that's more down to the designers and what they choose to do things for, than anything else to do with the product.
Yeah, and I'd also say what you just described there is request reply messaging, and that's actually where MQ is a sweet spot. It's data going in and then going back out as a result of something being processed. That's probably more of a messaging with MQ sort of model than a messaging and streaming with Kafka sort of model. Personally.
Yeah. In and out, I'm really cool with. It's just when the whole thing becomes sort of some synchronous paradigm that we have to support with latency concerns, and that's probably where my main worry bead is from. But from what you're describing here, that isn't what we're trying to use this for, and we've just got to be a little bit careful. Perhaps if we see designs coming down the line that overstep what we're trying to use this for.
Yep. There's definitely, good use cases for both, but they're not the same tool. They do things quite differently. And that's kind of what that one BA session is. It goes into some of the nitty-gritty details about the differences.
Yeah, great. Okay, well, we've overrun. I don't know if there are any more questions, Nick, but it's probably time for everyone to go and get a coffee before the next CICS session. So Mark, thank you so much.
You're welcome.
I found that really informative. I don't know about everybody else, but it certainly played into a lot of things that we're looking at the moment. If you could all fill in your response forms, that would be great. There's loads of prizes to win, and we're back in 25 minutes, unfortunately, not half an hour, to talk about the testing tool Galasa with James, and I think possibly Will Yates, if some of you know him, is going to make a guest appearance as well in the session at 10:30. So thank you again, Mark, and see you all again in 25 minutes. Cheers, everyone.
Thanks, Mark.
Bye.